Okay, so this one, it says the recurrence relation below models PN in a financial context after N time periods. So you can see you've got, okay, so you've got a recurrence relation there, which is true. You've got the N+1 rule. Okay, and it says all constants A, R, and D are greater than 1. So that's good. So they're not a negative number, so that's all right. 4 options of what the value of PN could represent are listed below. So how many of these 4 options could be represented by this recurrence relation? So pretty much if you look at your summary sheet for finance, you could pretty much look at your summary sheet and look at all the recurrence relation formulas, and anyone that has this sort of basic pattern or recurrence relation, I should say, anyone that has this sort of setup it could represent. So if you went to reducing balance and you looked at your recurrence relation formula, it actually says that it is this. So it's Vn plus 1 equals RVn minus D. So sorry, that's an N. So that looks like the same formula. You can see there's an R, there's a D, there's a thing. So that one, yep, it could be that one. If you look at annuity, an annuity, so really that's the same. An annuity is you gain interest with that big R, and then you minus a payment. So that's the basic setup for a recurrence relation in annuity, and we've got that there. If you look, so that one could be, if you look at recurrence relation for unit cost, it says Vn plus 1 equals Vn minus D. So that does not look like the pattern up there. So it can't be that one. And if you look at a perpetuity, its Vn plus 1 rule has a basic set out like this. So, yep, it could be that one too. So there you go. How many? It's 3. All right, so just look for that. The other things I've noticed in other exams, just why we're here and talking about it, a perpetuity. So if they say, like, say PO equals A, just for example, P1 also equals A, P2 also equals A. Just remember that. The perpetuity, they always stay the same. So you might have to remember that fact in some of the questions. And I think it's come up before, so I just wanted to say that. This next one, Todd invests $450,000 into an annuity at the start of 2024. The interest rate is 3.75 per annum, compounding monthly. So you should hopefully, we're getting near the end of finance, so just start popping. You're going to be using Finance Solver probably, so let's pop in those triggers so that we can remember. He will receive regular payments, so we know he's going to get a payment, and for the annuity is going to last 15 years. In which year will the balance of the annuity first fall below 350,000? So in which year? So when they say that, obviously, yeah, N is going to be your question. Okay, so if I wrote out everything I need for Finance Solver, so if it's N, I need the interest rate, so I've got 3.75, PV, all right, good. I know he started off with investing 450,000. The payment, now he says he receives payment, but I'm missing that. I don't know that. So there's something I'm missing. And FV, it says in which year will the balance first fall below. So that's, well, we know when is that going to be 350,000. All right, so we've got that, and PPY is 12. So because this is the question, I'm still missing the payment here. So I'm going to have to be able to work out payments. So off I go to find out what actual payments are. Now, because they told me it lasted for 15 years, I'm going to find what the payments were. Okay, so this annuity would have lasted 15 years for monthly, so PPY, We know the interest rate was 3.75. We know PV was she invested that much money. Now, the payment is what I'm trying to find out. And the FV, because she wants it to last for 15 years, so if I've gone 15 years, it should be 0. And PPY is 12. So when we do that, we get the payment. We find that that is 3272.50. So now we have that payment. We can pop that back into our scenario. So 3272.50. So we end up with 49.61. Now it said when in which year. So if you do 49.61 and divide it by 12, you're going to get 4.15 years. Okay, so her annuity started in 24. So if you add 4 years, but she doesn't quite go over, so she's still in the 4th. She hasn't made it to the 5. So it's going to be in 2028 is when the 4 years, because if you go to 2029, she will have gone past that. So it's sometime within that, after the 2028 year. Okay, so there's that one. All right, and now we're into this one. So this is the last question, so probably going to be a little bit harder as well. So Jared invests $14,000 into an account earning compound interest at a fixed rate per time period. The graph below shows the balance of the account for the 4 of the 5 time periods after the initial investment. The information for time period 3 is not shown, so we can see that's missing. So immediately after interest was calculated from the time period 3, Jared added an extra one-off payment. So this was like following a normal, if you look at so this was following a normal path. Then you got to this answer. Then they added a little bit extra, and then you got to here. So what we want to do, we want to know what that extra amount is. So let's have a look. We want to probably first, if we can use Finance Solver, and we want to know, we don't know what the interest rate is, so we need to know what it got to when it was 3 years. So if you look, I'm going to use Finance Solver to first find, so let's find the interest rate. So if you have a look, so if I go in, what I'm going to use, I can just use 2 of these time periods. Now, it doesn't matter that I don't know whether it's monthly, weekly. All I know is that it's between one time period. This interest rate is what I'm trying to find out. I'm going to say I invested this for, is this an investment? Yeah. I invested this first, so this is negative 14,000. And they weren't making any payments, so 0. And FV, after one period of time, this is how much had gained. And I'm just going to leave PPY as 1 because I'm just saying everything's 1. So I end up with, I find out the interest rate is 8. So now I know the interest rate. I want to find out what happens after 3 time periods. So I'm now going to go, all right, when it's 3 times period and the interest rate is 8, and we started at this 14,000 and the payment was 0. We want to know what it's got to, and PPY. I'm still just saying it's 1, whatever. We've done 3 periods. That's okay. So we end up with, this is what we could, we know that 1763, 5.97. So when we got to the end of the time period, it was this. 17,635.97. Okay, so some extra money was added. So we want to know how much extra was added in, and because then you got to period, sorry, so you can see it. So then we got to period 4. So what we could do is we're going to, we just could pretend to start again. So we're going to pretend to start again at the third payment, right? So if we pretend to start again and we go, now we know after, so I'm going from here to here. So I know it's one time period. The interest rate is still stayed the same. Now I'm just going to say PV. I don't know what the PV is because the PV is the third year amount plus the extra. So that's what I'm going to find out. And if I do, there was no payments and PV was, we know it ended in this. So I'm going to say what the end result was because they added interest to the payment and then PPY, we just keep as 1. So we end up with this being 17,860. So then the difference between, that's what it started at, but we know it was there. So the difference is how much extra, oh God, sorry, they put in. Oh my God, I'm writing all these numbers wrong, sorry. So 4 year, it said it would have started at this, but we know we only had this in there. So the extra payment is the difference, which is 224.03, which was